You'll need to turn that on at like
turn
the
that on,
bottom.
yeah.
There's like light up blue at the end.
Hey everyone, welcome to EdinburghJS and a special welcome to the live stream viewers, of course. My name is Cameron. I'll be the host of this evening. So we've got a talk lined up tonight from Nick around state machines. But first, I just want to hand it over to Gavin, who is from our wonderful sponsor, TravelPerk, who are providing the beverages and pizza you enjoy. Thanks, Gavin.
Hello, I'm Gavin. I'm a senior software engineer at TravelPerk. And yes, we're hiring at the moment. I'm not a recruitment person, so I'm not getting commission off this or anything. But if you're interested in open roles, you can scan the QR code or chat to me or Tony, who also works here. And Agata will be floating around as well. She was letting people in on the way in. Yeah, so if you've got questions about what it's like to work here or yeah, like what technologies we use and stuff like that, then feel free to grab us and we're happy to talk about it. Yeah, and I hope you enjoy the talk. And yeah, I think there's the pub afterwards and stuff. Feel free to grab like drinks and pizza if you haven't already. Thank you.
All right. I should also have specified when I said earlier, pizza is through there. It's not the easiest to find, so if you want to get there, it is through there. So please welcome our speaker for this evening, Nick Worral, who is going to be delivering a talk on modeling logic with state machines.
Thank you very much. I think I'm using this one.
Oh, are you?
Yeah.
Sorry.
Cheers. Thanks very much. So yeah, my talk's going to be today on modeling logic with state machines, and we're primarily going to be looking at it from a front-end perspective. Using the XState JS library. So here we go. Who am I? So I studied mathematics at Warwick University about 10, 12 years ago, not really counted since then. And then after my degree, I wanted to do something completely different. So I went on to cruise ships and I started playing piano. And I was a music director in the show band that they have on ships. And then in 2017, I moved to Edinburgh with my Scottish wife, who was also in the same band as me, and we got married, moved to Edinburgh, still working on ships, but have Edinburgh as a base. And then in 2020, the whole world, you know what happened, and there were no more cruise ships, so I needed to find something else to do. So that's when I became a software developer. So now I'm a front-end engineer at Webinar Geek, which is a Dutch-based company, and they provide a web-based platform for hosting webinars. This is primarily like targeted as businesses, so it integrates with all their marketing tools like MailChimp and ActiveCampaign, stuff like that. But we have a streaming application in Webinar Geek, and that's what I'm going to be talking about today, and how we use state machines to kind of build that out. So I like coding, music, board games, and traveling the world. So if anyone else likes those things, I'm sure we'll get along. So first off, what is a state machine? I'll just do a quick poll. Has anyone heard of a state machine before? Lots of people. Has anyone used state machines at work? Less people. Cool. So the basic definition from a state machine, and this is like a 60s definition for what they were used for in terms of like finite automata back in the day. So you have states, which are a finite collection of behaviors. They could represent pretty much anything. Just think of them as like nodes or behaviors or something like that. You have events, and this is something that can happen which can change a state. And then you have the transitions, and these are the rules that the events have to follow in order for one state to transition into another. Normally, this is represented by some kind of table, like this. We're going to talk about a turnstile. So the turnstile is something that you go to a train station, you put a coin in, and it lets you through. If you try to go through without a coin, then you're stuck. So a turnstile has two states, the locked and unlocked state. So when you're in the locked state and you try to push it, you're not going to get through. It's going to remain in that locked state. However, if you take your coin, stick it in the turnstile, it's going to transition into the unlocked state. So when you do push it on the unlocked state, you're going to get through, and it's going to transition back to the locked state. And if you're in the unlocked state, you put a coin in, you're going to remain in the unlocked state. So that table pretty much describes what a turnstile does. However, with state machines, these are like very visualizable things, so you'll often see them like this. So you've got locked and unlocked, which are the boxes over here, and you've got arrows between these two states, which are the names of the events that we have, called push and coin. So again, if you start in the locked state and you push, you're going to remain in the locked state if you follow the arrow around. If you put a coin in, you go to the unlocked state, and if you push again, you go back to the locked state. So simple. So everyone knows how a turnstile works, and we've not even done any coding yet. So the state machine's good, and that was like a 60s definition, but now we've got a few more things to make the turnstile more smart. So I'm going to talk about these things called extended state machines or state charts, and I'm probably just going to refer to that as what a state machine is. So with an extended state machine, you've got also different types of states. So you've got these things called child states, which are kind of, within that state, you can have a sub-state machine operating on that child state. You've also got parallel states where you can be in two states at the same time. So rather than just a single linear line of states, you've got a bit more expressiveness for how you want to talk about your states. You've also got guards, so you not only have the transition table, you've also got internal variables which are going to affect how a transition is going to run as well. Actions which are like side effects, which can happen on transition, or the entry of an exit of a state. And then finally, your context, which is where your internal variables that could be used in actions and guards. And always best, we'll go back to our example with the turnstile. So say the turnstile now has some knowledge about how many coins it's got inside it, and say it needs like £1 to get through it. If you put in 50p, you're not going to get through it straight away. You're going to remain in that locked state. However, if you put in another 50p, well, the amount has grown to £1, and you're going to go to the unlocked state, so you're going to get through it. And even more so, in that unlocked state, we can keep track of how much money we've got in it as well. So if you keep on putting like £2 or £3, you can let your whole family go through with that unlocked state until you've gone through 3 times, and then the next person is in the locked state. So here we have a demo. Sadly, we've got the little dinosaur, which means it's not working, probably because I'm not connected to Wi-Fi, but that's OK. So what we have here is the turnstile like kind of visualized. I asked AI to do this. So first, I made the state machine, which you're just going to have to imagine this state machine over here. And now we have a UI representation of it, which, yeah, I asked AI to come up with. And it was kind of easy to hook it together from that. So if I do my things and I put in 50p, you can see I've got 50p coins in. And if I try to push the turnstile, no, we need more money. If I put in another 50p, it's telling me to proceed, and I can go through. If I try to go through again, no, it's not going to let me do that. And if I put loads more money, then I can go through multiple times until it says, I need more money. On the right side here, I was going to demonstrate the state machine working at the same time so we could visually see what state we're in, but sadly, not today. So let's move on. Cool. So state machines, you can see, are the blueprint. They define like the logic and the behavior of the system even before we started implementation of it. So they're easy to understand. They provide that clear visual structure for how the system should behave with your locked states and your unlocked states. They're predictable and reliable. They're guided by the event, so they're always going to do the same thing all at the same time. So if you put in that 50p 2 times, you know you're going to be able to push the turnstile. They're maintainable and extendable, so you can grow the state machines just by focusing on a particular part of the state and working on it like that. Normally, if you're building a React application, you'll find that lots of times you've got use state everywhere. You've got use effects, which are triggering all your side effects, and it quickly becomes a mess because this is scattered around components. With the state machines, it's all in the same place. Or if it's in multiple state machines, you know they're all in the same place. You can also handle edge cases as well. So say someone puts like a button in the turnstile. Well, that's not a coin. So maybe you have an action or a side effect to spit it back out again. And they're also great for communicating with other team members. I know we're all developers here, but I can confidently say I would be able to talk to the designer, talk to the project manager about turnstiles. And I'm sure you'll be able to right now because we all know how they work. So that's a turnstile. I'm going to talk about something real world now, which is about Webinar Geek and our tech stack and evolution. So yeah, as I said, in 2020, that's when the internet was booming because of COVID, and the company kind of grew from its like 1,000 customer base to 2,000 to 3,000, and they needed a better software to kind of manage their streaming application. Originally, it was built on like a Ruby on Rails monolith, so there was JavaScript in so many different files. It was kind of cluttered all over the place, and they couldn't really extend the streaming application that they built. So we rewrote the entire front end with React, because you've got a better management of state, you've got reusable components, and it's also extendable. We still use Ruby for the back end, mainly for these APIs. So APIs calling for initial data about what the broadcast is, information about the broadcast, handling chat messages with mutations. And we also have a Phoenix WebSocket server as well. So so we're able to broadcast real-time updates to all the clients within the front end, and we'll get those updates via React. We also use Daily as our WebRTC server provider. So that's providing us live video and live audio streaming too. And finally, we've got EdinburghJS, which is a JavaScript video library, which allows us to play live streams and webinar replays as well. So we've got quite a bit of stuff going on for our tech stack, for our streaming page. And we've got to orchestrate lots and lots of different events coming from multiple different sources. So in the terms of React, we've got these user interactions when people are clicking on buttons. And what they can do there is they can start the webinar, they can send a chat message, or if there's a problematic viewer in the audience, maybe from a rival company, you can ban that viewer. We've also got the webinar updates coming from Rails and Phoenix, so saying to the clients when the webinar has started, when there's a new chat message, and if they are that problematic viewer, and we want to be able to shut down their page quite gracefully and not let them back in. We've also got WebRTC events, so when the video stream's loaded and we know it's safe to show the presenter to people. When someone started talking, they become the active speaker, and maybe we want to highlight them with a box around them. Or if the device is disconnected, someone's yanked the microphone out of their laptop, we want to be able to tell the user, hey, you should plug your microphone back in, or we're going to switch the microphone for you. And then finally, we've got the video player, the EdinburghJS stuff. We want to be notified when someone's pressed pause on the video, when the time's skipped. During a webinar, we've also got various interactions that can run, like polls and quizzes, and maybe like a nice pop-up to show a link for people to click on. And we want those to be faithful to the replay as well. So when you get to a certain point in the webinar when someone started the quiz, then we also want to be able to start that quiz on the replay as well. So we've got to listen for the events for when the time has been skipped or when you've reached that time. So a lot of events going on here. And we've also got the standard web APIs like set timeouts. If an API call has failed, if the page suddenly becomes from hidden to visible, then we want to double check that we've not missed any WebSocket messages, such as the one that says the webinar's ended. You should not see the presenters anymore. So here's a couple of examples. I'm going to go through 2 examples of what we use and how we use state machines to build them. So when you're building something with state machines, you always want to start with the requirements of what it should do. So for starting a webinar, what should it do? So initially, the webinar is not started, and the viewers will not be able to connect to the WebRTC service, because the presenters might be talking a bit about the webinar. Once the webinar starts, the viewers will connect to the server, and then we'll be able to see the presenters. And once the webinar ends, the viewers will disconnect from the WebRTC server. And that's very important, because once a webinar ends, usually the presenter takes a big sigh of relief, normally scoffs a chocolate bar in their mouth or something like that. I've seen it happen before. So our simple state machine for our webinar state would look like this. So you start in the not started state. Once the webinar started, you go to the live state. Once the webinar is ended, you go to the ended state. Pretty simple. And again, it would be nice if I could get this diagram to work, but I'll show you like how it looks for a simple button. So you start the webinar, you see the webinar starting, you stop the webinar, stopping the webinar, and then it's finished. On those gray buttons, that's the process of calling an API call, because when you start a webinar, it doesn't automatically start straight away. You've got to make some server request to Ruby, and then receive a confirmation from the WebSocket that the webinar has in fact started. But we as UI developers, we want to show to the users that something is actually happening, so they don't mash the start webinar button. all the time. So that's why the state machine is really good for modeling like these API requests as well. While you're in a process going from a not started state to a started state, you've got that intermediary time where you can give some information to the user. Also, perhaps it's the webinar doesn't start for some reason, and you want to handle the edge case of saying, well, something went wrong. Perhaps we get like a nice message from our API that says, the webinar can't be started because it's already been started once. So we want to handle that and show a notice to the user. Maybe we shut down the whole page because of that. So we can pretty much do everything, and we can handle those edge cases really nicely. This is what it looks like in a nice sequence diagram, which lends itself to a similar concept to the state machine diagram that we have as well. So we start with our user, who's going to be the presenter. They're going to click the button which says Start Webinar. Our React component is going to get that from the onClick handler, and then from there it's going to send an event to the state machine called Start Webinar. That webinar state machine is going to post an API request to Ruby, and while it's doing that, it's going to transition into that starting state. So React's going to re-render the UI to show starting webinar. Once the webinar has been started, and it's all fine, Phoenix is going to broadcast that event, webinar started, to all the clients. And from there, we're going to transition into the started state so we can re-render the UI to show stop webinar. So that's how most of our interactions work. So there'll be a similar one for like sending a chat message where you will post some API endpoint to Ruby. If it's successful, then it's going to broadcast the client to every single client that there's a new chat message, and then you can see it. Here's what it looks like in a bit of code. So as I mentioned at the start, we're going to be using XState as our JavaScript library for making these state machines with code. So on the left, we've got XState, and on the right, we've got our React component. So we start off with this function call called createMachine. So this is going to define what the states of the machine are, what the initial state of the machine is, and the rules for the transitions. So we start off in this not started state, and that's got one job. It's going to listen for when you want to start the webinar. So it's going to be listening for that event, start webinar coming in, and it's going to move to this starting state. This starting state has got a bit more going on, and it's got this keyword called invoke. And that you can think of that as like calling some API endpoint. And the source is going to be called start webinar. And that can and that's going to be some kind of promise that can either resolve or reject. So if it resolves, you're going to follow the on done path. And if it rejects, you're going to go to the on error path. So assuming it resolves, you're going to go to the live state. And if it rejects, you're going to go back to that not started state, this one, so they can maybe retry again, or maybe you go somewhere else. But the good thing about this is we've got this actions, which is we can call any number of side effects here. So in this case, we're going to show a notice saying something went wrong. Could be anything, depends on the API error, and go back to that not started state. So the user knows what's gone wrong. And then eventually we'll be in that live state where we can show a different bit of UI. So that's the state machine definition. On the right side, we've got the React component, so the start webinar button. The way that we use the machine within React is we're going to wrap it around with this hook called useActor. You might think this looks similar to like useState or useReducer, and it's modeled this way exactly. So on the first destructured argument from the hook, you've got state, which is the current state of the machine, including all of its internal variables. And on the right side, you've got the send function, which allows you to send events to that state machine for it to transition and possibly do something else. So so we've got that one. And then we've got different paths that we can follow within the state machine. So this reads like if state matches not started, that means if it's in the not started state, we're going to return this bit of UI, which is going to be that start webinar button, which is going to have an on-click listener to send the start webinar event to the state machine. If we're in the starting state, then we've just got a button which doesn't really do anything, and we've got like a nice ARIA disabled attribute, which we can use some styling to make it grey, which is really nice. And it's called webinar starting. And if we're in the live state, we've got a stop webinar button as well. So that's the whole thing. So now we know how to start a webinar. I'm going to talk a bit about XState and say why it's why you should be using it as like your state machine library. So it's very feature rich. So it supports like the child parallel states, so being in two states at once and having nested states. It supports the guards for checking when you can transition properly, and actions and actors. So you can think of actors as like that invoke thing. So an action is something where a side effect where you don't really care what the outcome is. It's like you fire it and then you forget you ever did it. An actor is more where you care about the outcome, like a promise. You care whether it resolves or rejects, and you want that bit of data out of it at the end. It's based on the actor model, which is this paradigm for isolating logic and handling, and it's used for handling like complex async behavior. We're not really doing anything distributed within the front end because it's all within React, but we will have lots of different state machines all like kind of spread out over our project. So it's really good for handling messages between two different state machines. It's SCXML compliant, which is like a standard for state chart semantics and how they work. We've got really nice side effects management. As you've seen, we've got nice actions and child actors which can be handled in a predictable, testable way, like that notice that's being shown. We also have really strong TypeScript safety as well, and that's one of the best things that you kind of get from it. So anytime that you try to say a state matches this thing, you'll get autocomplete, and you'll also get those TypeScript compile time errors when they don't match, and also on your events that you're sending to the state machine as well. Events can also have certain payload, and you'll get TypeScript safety on there too. And then finally, it's framework agnostic. So our streaming application was built in React. However, these slides are built in Vue. So it was really easy for me to get my state machines, put them in my presentation, and then write a Vue component for it. And it works with Svelte or no framework at all, just JavaScript. And then finally, you've got, well, we didn't see them today because it wasn't working, but you've got some really nice visual editing and inspecting that you can do, so you can see what state your state machines are currently in while you're running your application. This is a quote from one of my colleagues, Boa. You get so much more reliability from your logic because of the nature of state machines. And if you have an XState experienced team, you start thinking in terms of state machines. And that's very true. Whenever we start building a feature, we're always thinking, what does the state machine look like for this? And then we'll always go to our designer and product owner, who aren't necessarily technical in JavaScript, but they can see how we're going to build it. And then we're going to match some designs to certain states from the designer's UI. And then process what the sequence of events should look like. I want to talk about this one quickly, because this is one of my favorite features that we have on our platform, and that's called Viewer on Stage. So that's when you're giving a webinar, and a viewer, you can invite a viewer to actually come on stage and be a part of the webinar. Maybe they've got a question that they want to ask the presenters live. One of the best ones I've seen is like a marketing team to help people build like landing pages together, and they would get people from the audience to ask a question about their landing page, and the viewer could screen share their landing page, and they could get real-time feedback from it. So this is one of my favorite features that we have in our platform. So here's how it should work. So the presenter should be able to select a viewer and ask them if they'd like to come on stage. The viewer should then be able to see their camera and microphone and confirm if they're OK. At this point, it's important that they're not visible to the presenter, because then there's like privacy issues there. You can just click on a viewer and see what they look like. After the viewer accepts that they're happy with their settings, they'll click an accept button and make them show them to the presenter. And the presenter also being happy with how the viewer looks, you want to make sure that they are presentable as well. They can add them to the stage, and that means they're viewable by everybody. And the viewer should be able to, and then, yeah, indeed, the viewer should be able to be seen and heard by everybody. So here's an example. So say we've got our stage here, our presenter view here, and our viewer view here. So currently, there's a presenter on the stage, handsome-looking guy. So I'm going to invite this viewer on the right. So waiting for the camera to start. Oh, there he is. He's looking at the laptop with his sunglasses on. And they're going to accept the invitation. So now the presenter can also see the viewer at this point, but notice they're not on the stage yet. The presenter's got to be happy with them and say they're happy with them. They can bring them on stage, And there they are. So they're able to be seen and heard by everybody. Once they're done and they've asked their question, we can remove them from stage. And once they're complete, we can bring them back on if we like. But once they're completely finished, then we're going to uninvite them. And then they're back to how we started. And this state machine handles like many flows as well. So say if we invite the viewer and the viewer doesn't want to actually come on stage, then they can cancel their invite and they're back to the start again. Or if they invite the viewer accepts, and the presenter's not happy with them, then they can uninvite them. So we can handle many different flows with this state machine. So again, I'll show you a bit of code for how it looks in XState, and you get to see some of the type safety over here as well. So when we start with the state machine, normally we start with what the types are, what its internal variables are going to be, and what kind of events we're going to send to the state machine. So in terms of the internal variables, the context, we're going to have a viewer ID, which is the viewer that we're inviting. However, with our platform, we actually need a session ID, which is something from the WebRTC service to actually add them to stage. And those don't always coincide. When the viewer ID is always going to be the same, but if you refresh your browser, you're going to get a new session ID. It's like a real-time thing. So we've got two different IDs to keep track of. We've also got lots of different events that's going to happen. So the presenter inviting the viewer with a certain viewer ID, the presenter uninviting a viewer, the viewer accepting the invite. At that point, we get their session ID from their browser session. We've got adding the viewer to the stage, removing the viewer from the stage, and a couple other events, like if the viewer disconnects from the browser, then we also want to be able to handle that on the presenter side, and also if the viewer cancels their invite. So once we've done that, we call this function called setup from XState, where we get to define what our types look like, so our context and events, and also all our promises and our APIs that we're going to use. We don't actually have to say what their implementations are. We just need to say, we're going to call this at some point. And the XState gives us a nice function called fromPromise, which allows us to convert any promise into something that can be called within a state machine. At the moment, I've just got these set to 1 second timeout, so they'll automatically resolve straight after that. And then finally, we've got our ability to kind of create the state configuration of how the machine looks. So from that setup function, we've got a property on it called create machine, and we're going to go through it. So first off, we give it an ID, and then we can say what the initial context is. And that's going to be type safe as well. If you try to pass like a number into the session ID, and it's got to be a string, then you're going to have some type errors over here. And then we also say what the initial state is. So the initial state is everything, the webinar's going as normal, no one's invited. So on the not invited state, this is where we're going to see like a child state or a parent state, a state with states within states. Then you've got a couple of things or one thing that you're happening first, like an idle state where you're waiting for that invite. So on that idle state, the presenter's going to invite the viewer. After that, we're going to go to the inviting state, but first we're going to do a couple of actions. So the assign key function, that allows you to set some internal variables in our context. So what we can do is we can pull out the viewer ID of the viewer that we invited and assign it into our internal variables. And this other one, this log function, I find really helpful because that you can set it up in such a way that it goes to an external log service, so you can actually see what people are doing in your application and kind of following through, like tech support, they can follow through the logs to see what people are doing, and if anyone gets stuck or there's a bug that someone's encountered, we can follow through and see what they've actually done to see what's caused that. So once we've invited the viewer, we go to the invited state. We're going to invite the viewer, call that API endpoint, pass it like a bit of input, which is going to be our viewer ID to our API service, so we know who's going to be invited, and hopefully everything should work, and we'll go to this invited viewer state, which is going to be down here. If it does error, then we'll also get a nice log message that can say we failed to invite the viewer. So now we know if we see that in our logs, we can look at like the API endpoint and say why did that fail, and kind of go know where the problem is. So in the invited viewer state, this is going to be another parent state with many things that we can do. We can straight off uninvite them, in which case we go through an uninviting flow, similar to what we've seen before, just calling an API, letting it resolve, and then once it does, go back to the idle state. Or the viewer could cancel their invite at any point, in which case we go to the not invited state, back to the one we were just in. But if all goes through correctly, then we're going to wait for that viewer to accept the invite. At that point, we'll get a session ID that we can add to our context, and then they're ready for stage. If the viewer disconnects at any point, then we've got to wait until they refresh their browser to give us a new session ID. But then the next two states are just on stage and off stage, and this is simply just waiting for just adding them to stage, calling the API endpoint, and they'll be on stage. And while they're on stage, we can remove them from stage, calling the API endpoint, taking them off stage, until we call the uninvite viewer state, at which point we'll go through a small API endpoint and be back in the not invited state. So that's the flow of how viewer on stage works. There's a couple of more implementation details that you need to get, but starting from this, this is kind of like a simple flow of how it worked in the product manager's head. This is how it works in the designer's head, and we can make he can make designs for all of these different states as well, and we can map them up in React in the correct way. So being a state machine as well, we can also add many extensions to this. So say there's no camera or microphone permissions, then we can catch the error when the viewer tries to connect. Perhaps they've got it blocked on their browser, so we can point them in the right direction to say you need to refresh your page, get it up and running again, maybe point them to the site settings. We can add in stage requests where viewers can actually put up their hands virtually, and then the presenter can see a list of people that want to be invited, and that corresponds to having an extra state just before the invited step in the state machine. You could possibly join with audio only. Maybe you want to be heard but not seen. So we give like a small checkbox to say I want to join with audio only, and at this point, it will just be like an extra bit of payload on the event to say, I want to join with audio only, which we can handle in the correct way. And we've also got like a meeting scenario. So say we're doing like an internal conference, kind of like we're doing now, but imagine if we were doing this virtually and people wanted to come on stage at some point to ask a question, or it's an internal company, then you don't want to have to go through the process of making all these invites. We just allow people to do that, and we use that for our internal like daily stand-ups where everyone can come on stage and talk for their bit. So yeah, so that's the viewer on stage, and now our whole platform is composed of multiple different machines. So we've got the webinar state machine going from the not invited to the live to the ended states, and we're also emitting these events that say the webinar started to other state machines so they can respond in a correct way. So one is going to the WebRTC service to say you're going to connect to the call now. So we've got all these different paths kind of going through different state machines. We've got lots of chat machines which are listening for chat messages from different categories. We've got like a public chat, we've got a presenter chat, we've got a private chat, which is contact between the viewer and the presenters. And we also allow you to send new messages or receive messages on these channels. And we've also got the WebRTC machine. So yeah, I mentioned you can join the call once the webinar started. Once the webinar is ended, we automatically destroy that connection. And we also do different things like managing your devices on here with the error flow of checking your camera and microphone works. And you can also update the webinar layout. Say you've got presenters side by side in a grid and you want to switch to an active speaker layout, or maybe some presentation layout where you've got some slides and you've got yourself in the corner to give more room for the presentation. We've got different machines for that. Plus over like 100 other state machines controlling different parts of it. So controlling presentation, controlling pre-recorded videos, controlling polls, quizzes. You can really build up like a really complex application with these small parts which are isolated from each other and loaded when they need to be. So that's the main part of my talk. I want to end on this thing I came up with at the weekend. Does anyone also study mathematics? No, okay. So this might go over some people, but you see what you make of it. So this is an experimental mathematical analogy. about manifolds. So a manifold is like a space which may be complex globally, but it always is simple and locally understandable. So I always refer to like the Earth, the thing that we're living on, the surface of it. That's kind of complex, so it's quite big, but we locally understand it via these maps and charts that cartographers have created. So we understand like a map of Europe, a map of the UK, a map of Edinburgh, just our local regions, but they all stitch together in some way to make up the Earth. And yeah, these are called charts. You can also think of like maybe in the prehistoric times we could have been living on a torus or a donut shape, the surface of a donut. We wouldn't know because it looks locally very similar to like a sphere. It's smooth and curved, but it's very different. You could fly a spaceship right through a donut, but you can't fly a spaceship right through the Earth because it's a sphere. So an atlas is like kind of like a collection of the charts that cover the manifold in some way, and the charts are all compatible with each other. So maybe the cartographers didn't agree back in the day, but once we have like a big atlas and it's all created by the same person, these are all maps which work together. So here's the analogy. So going back to state machines. So when you're developing software, you've got all these things called user stories, which are kind of like the charts on a manifold. They're like linear, locally valid narratives, and they're the paths that people take within your application. So the webinar's not started, to the webinar starting, to asking some chat messages, starting a quiz, to the webinar ending, to you finishing, and that's it's like a user story. And that's the path that you take through your application. The software state machine is kind of like the manifold. It's the structure that supports all these valid user paths and may perform like different overlapping stories, and they've all got to connect some way. And then the developer is someone that constructs this atlas, takes all these user stories, constructs a software system from it, from all these charts, which are like in some kind of coherent space, which is like a good application. Maybe there's still a few bugs or something like that, and those kind of be, if we're doing the analogy correctly, there'll be like singularities that you can, I guess, chop off. If you're doing like some integration along a manifold, you just kind of get rid of that part and then fix it. And then there's also some more analogies where testing becomes like kind of proving that a local patch of the manifold behaves as expected. Maybe that's a mathematical proof. Maybe we can make some testing framework which is really rigorous, that it's mathematical. And refactoring is kind of like changing like the coordinate system of the manifold. So it still supports everything, but it's done it without changing its shape. Like you wouldn't change the software system from a sphere to a torus because that's changing the whole shape, and it's going to have different. It's going to change how the user stories interact. But if you just bend it slightly and stretch it a bit, then it's not going to change its shape. My other favorite one is tangent spaces, which you can imagine a tangent space on the Earth is where you can walk. So all the directions you can kind of walk in like a plane of where you can go. However, in like this analogy, then it's going to be all the possible events that you can send to your state machine, all the possible ways you can get from one state to the other. So I'm going to explore that a bit more, and if anyone wants to talk about it in the pub over a beer after you, then maybe it will start to make more sense. So there's my quote. Just like a globe is built from local flat maps, your app is built from local user stories. But it only works if they all fit into one coherent system, and that's what the state machine helps you provide. So that's my talk. I've got a bunch of links up here, one to go to XState website, so you can start playing around within JavaScript. We're also developing a bunch of like tools to help you work with XState. We've only got one on there so far, but I plan to add a few more. This one allows you to declare like React components in a declarative way, rather than going through that if in this state do this, if in this state do this. It kind of mimics the state machine view with TypeScript. And I've also got like a nice TypeScript plugin which allows you to jump between states in a state machine, jump between implementations as well. So follow the QR code if you want to get those links. And the presentation is part of this link as well. It just links to this slide, so you can click on those easily. And that's it. I think it's time for Q&A. Yeah.
I've got Mike here if anyone has any questions, but that was a brilliant talk. Thanks so much, Nick.
Thank you very much.
Any questions? It's for the viewers at home.
Oh, sure. Yeah. Whoa, sorry. It's louder than expected. Yeah, so I was wondering, what do you do, for example, if you need to kind of say someone like refreshes the page, you need to get you need to get all the state machines back into the state that they were before that they refresh the page. Like, do you store state on the server? Do you use like some kind of client-side caching mechanism? Like, how do you do it?
Yeah, good question. Normally we just go back to the basics and call our API endpoints again, but I want to toy with the idea of actually, instead of calling our API endpoints, the API endpoints actually give us like some kind of machine states, so we don't have to build it up on the client again. We've kind of got those stored, and XState actually gives us a really nice way to start a state machine within a certain state. So if you are in the live state, we would get a machine which is in that live state with like the correct timing on it, for example. So there are really nice ways to do that. But right now we're back into archaic, just start with the APIs and rebuild it up again. You can also reason about a state machine via like the sequence of events that has happened towards it as well to arrive in the same state, because they are reliable and predictable. But, yeah, cool.
Any more questions? So a half hand over there? Yeah.
It's just a follow-up to that one. So
Yeah.
basically, on each of these state transitions, are you sending some kind of message to the server to synchronize with the server so that it knows where the user is?
Yeah, kind of like the server would have some representation of what the webinar looked at that time, or maybe like the sequence of chat messages. So for us, it looks like just gathering all the chat messages from the API, loading them into our client-side state, and then synchronizing them when like another chat message comes in via WebSockets. If that makes sense and answers your question. Or?
I'd have to look into it. First of all, I just want to say I've been to a few of these. This is by far the best talk I've ever been to. Like, by far, is really interesting.
Thank you very much.
Yeah, I really like this idea of state machines. Yeah, the only other thing I was going to ask, well, I was going to ask a few things, but I'll let other people go for it. But the first thing I want to ask is, are these state machines confined to a single page, or do you basically have these like living somewhere and then like any page can import this state machine?
Yeah, I mean, they're just like JavaScript functions, so you can run them like within the module scope and get a reference to it just when you load that particular file and start running it. You can also have them stored in like a React context, so it's kind of like shareable between things within the context itself, so you can reference it. Maybe you do that when you've got different, multiple contexts with like different machines. Maybe you start a state machine for each of your chat messages, something like that. So it can live in wherever you like, and it can also live on the server. I want to experiment a bit more with storing a state machine in the back end and then having it synchronized to like client side, so you don't actually have any of the state machines living on the client side. You just have these events, and it's kind of like splitting out these templates and just updating what it needs on the server, so the client kind of becomes kind of dumb after that.
Yeah, on that, sorry, I will shut up in a second. So on that, like, what happens if two state machines get out of sync, or can they get out of sync? Because like I can imagine that you're in a state, and then I don't know, like you said, you refresh the page or whatever. I don't know, and the webinar like has ended, and you come back, and your state is no longer valid. Like, how do you detect that?
Yeah, good question. I guess it depends on how it's like kind of built up. I know there's like whole like theories about distributed systems of like how to keep multiple things in sync and like reconciliation with some kind of like process. Maybe like the interesting one to say is like we've got a state machine which controls like an internal clock for the on our streaming page to know when the webinar is actually going to start. So we've got automated webinars which starts a video at like 9 p.m. on a Friday, and we've got like a clock that keeps on running. However, if you like close your page, then the JavaScript stops running. So we're using that page visible event on the document to say, okay, let's go and refresh the time and see what time we should be in. And it's like 9:01, so that's when we know, okay, the webinar's started now. We need to be showing the video. So there's different kind of mechanisms for like handling that, and I say it depends on each case by case.
Thanks.
Cool. Could you pass that? Oh, no, we got it. Yeah, there we go.
Thank you.
Cheers. Thanks, that was an awesome talk.
Cool, thanks.
Cheers. I'm just wondering, you mentioned that like there are like hundreds of these state machines that sort of run in the fully fledged app.
Mm-hmm.
Like my experience with state machines when I've used them before, especially sort of like in game loops and things like that, is that as soon as they start to get really hierarchical, then it gets complex really, really quickly.
Oh, yeah.
My first question is, like, do you have a state machine hierarchy in the stuff that you're building, or are they all separate? And do they have like sort of event emitters or something like that instead? And yeah, how do you handle that like jump in complexity as soon as like it's, you know, more than just a couple of pages that you need to do?
Yeah, exactly. So if a state machine's kind of getting too complex, then you can split it into multiple different state machines. Sometimes they might need to use some shared state, so sometimes things can be get out of sync, or you could have one base state machine containing all the shared stuff and then emitting events through there. Again, XState gives us a really nice, each state machine is kind of like an event emitter. So you, as a side effect, you can say, the webinar has started, or whatever you want to do, and anything listening for that will receive that as an event as well. So everything's entirely built of in events. But yeah, we've got everything kind of like modularized into like these small state machines which are doing like one single thing. We've got like these API machines which are running to get like an API endpoint and then resolving, and they're very like short-lived, like a few milliseconds, and they're gone. But yeah.
Awesome, thank you.
Cheers. Thank you.
Any more questions?
Sure. Yep. Maybe two questions. One is around testing. Like, do you, I guess, like in the scenario that you've given of like React with a state machine, do you test the state machine like in isolation with all the logic, and then just test that the React component is like rendering what you want given the correct state, or do you test that like all together as like an integration test?
Yeah, good question. Integration test all the way, because if you're testing your state machine's test and what events are being sent to it, then you can't really change it, and you're testing an implementation detail.
Sure.
Instead of so normally the process goes, here's a button, I'm going to simulate clicking that button, it's going to do something, and I expect this bit of UI to be rendered.
Okay.
Yep.
And then another question, in the example you gave where you could join like with or without video, I could see a world where like whether you're joining with video is like a state in itself, like you've joined with video or you've joined without video, or I could see you've joined is the state and like the context is did you join like with or without video.
Yeah.
Is that like a problem that you run into a lot, like debating what is like a different state itself versus like context on the state?
Yeah, another good question. I guess it comes with like building and modeling and seeing how the state machines will kind of get an experience with state machines to know how it becomes. Some of them are like really easy. So if you're keeping track of a count within your state machine, then that's going to be an internal variable. And especially because the state machines are finite, you can't have a state for every single value of your count. So yeah, that's going to be internal. There's some like Boolean flags that sometimes you want it as a Boolean on the internal variables, but sometimes you might want to model that as a state itself. And normally depends on if there's going to be any side effects like triggered, or if there's going to be certain events that are only possible in while the Boolean is true, while the Boolean is false. But if it's, we found that if it's just a case of like noticing if something's audio only and not showing any video, then we're just using that to kind of like not render the video, essentially.
Okay, thanks.
Yeah.
Any more for any more?
Yep.
Thanks. I've got one more, if that's okay.
Yeah, of course.
I think you've kind of touched on this a bit already, but when it comes to refactoring, how do you find that? Because it sounds like you have lots of sort of smaller, more modular ones. Do you ever find you have to like sort of move that module boundary, and is it sort of hard if you do so?
Yeah.
Yeah.
Yeah, it kind of depends on how well we've been testing something. We've got a lot of tests. We spend a lot of time building tests, so we know that if we refactor some state machine or split it up into two different state machines, then if we've done it correctly, then our tests should still pass. If they don't pass, then it's probably an implementation detail that we've done wrong as well. We're also in the process of converting lots of all the machines from XState version 4 to XState version 5, which was released like a year and a half ago or something like that. So those tests also give us confidence in knowing that we've done refactoring right. But I'd say tests are your best friend for knowing that refactoring is correct.
All right, final call. Okay, well, I don't think I'll be the only person who is entering npm I XState tonight.
Hey.
So yeah, that was an amazing talk, Nick. Thank you
Thanks,
so
thank you very
much. We'll be around here until probably around 8 o'clock, and then we will be decanting over to the Fountainbridge Fox, I believe, is the local pub. But yeah, thanks everyone for their time, and thank you to TravelPerk as well for providing both your wonderful event space and refreshments. Thanks for coming, everyone.
Yeah, thanks for listening. Oh, cheers. Thank you very much.